Recitation problem 4. A 650 kilogram elevator starts from rest and moves upward for 3.0 seconds with constant acceleration until it reaches its cruising speed of 2.0 meters per second. What is the average power of the elevator motor during this period? This system can be sketched by means of the following diagram, which is under two forces: the weight mg, which is a conservative force, and the tension T in the cable. Notice that the force that is exerted by the motor is represented by the tension T. The motor, which is usually mounted near the top floor, pulls on the elevator by means of the cable, therefore the tension. For this reason, the power of the motor is going to equal the work done by the tension divided by the time t. Since the work done by the non-conservative forces is not zero in this case, therefore I'm going to use the work done by the non-conservative forces in order to evaluate the work done by the tension. The work done by the non-conservative forces equal change in kinetic energy plus the change in potential energy. There is one force that is non-conservative, which is the tension. That is going to equal the change in kinetic energy, which is 1/2 mv final squared, minus 0 because the elevator starts from rest, plus the mgh final minus the mgh initial, which I'm going to choose to equal 0 as well. This means that the height from which the elevator started moving is going to be chosen to be the zero height. Notice that the height h is the only quantity that is not available to us to be able to solve for the work done by the tension. This height h can be solved for using kinematics. And the best equation tool that can be used to solve for it is y minus y0 equals 1/2 the v final plus the v initial times the time t. Notice that the height h is the same as the difference between the final y minus the initial y. Therefore, solving for the h final is going to equal 1/2 times the final velocity, which is 2 meters per second, plus the initial velocity, which is 0, times the time t, which is 3 seconds. This allows us to solve for the height h to equal 3.0 meters. Now it's possible for us to solve for the work done by the tension, which is going to equal 1/2 times the mass, which is 650 kilograms, times the final speed, which is 2.0 meters squared, plus mgh, which is 650 times 9.8 times the height that we just solved for, which is equal to 3.0 meters. Solving for the work done by the tension, we obtain 20,410 joules. Now let's put together those two quantities, the work done by the tension and the time, to solve for the average power of the motor. That is going to equal the work done by the tension divided by the time t. Solving for this quantity, we obtain 6,803 watts.